Classifying chemical reactions. There are two main types of methods for classifying chemical reactions. We can classify a reaction by what happens. And that's the classification system we've been looking at up until this point. We talked about precipitation reactions. A precipitation reaction is where you mix two aqueous solutions and you get a precipitate, a solid. That's what happens. In an acid-base reaction, an acid and a base neutralize each other. It's a neutralization reaction. In a gas evolution reaction, a gas is given off. That's what happens. Oxidation reduction reactions are a little harder to directly observe the oxidation and reduction, but combustion reactions are easy to spot. Combustion reactions are a subcategory of oxidation reduction reactions. Now there's a little asterisk. You should always pay attention to those little guys. Many gas evolution reactions are also acid-base reactions. Okay, so what can sometimes be confusing is that one reaction can fit into more than one category. It's a little bit like I used to have a Ford Windstar that we would argue about what color it was. It was teal. You've probably seen them. They don't make them anymore, but that just really dark, intense teal color. And it was used, so I didn't get to choose the color. I would not have chosen it. But it was easy to spot in the parking lot. But is it blue or is it green? Well, you could really put it in either or put it in both. It is blue and it's green. It falls into two categories. And so some chemical reactions fall into more than one category. So that's one system. The other system is by looking at what the atoms are doing. So in this scheme, there are 4 different types of chemical reactions. And I'm going to throw a word in here. Single displacement. I'm going to use the term single displacement. Your book uses displacement or single displacement. I prefer single displacement. So we have synthesis or combination, 2 different words for the same type of reaction. We have decomposition, we have single displacement and double displacement. And these are the generic forms of the equations. We're going to talk about each one individually. So in a synthesis or combination reaction, we have 2 things combining. So we have simpler substances combining, hence the name combination reaction, to form a more complex substance. And what we're going to see is it's going to have this form. We've got one thing plus another thing, and we get one product. So if you have a reaction where there's only one product, you've got multiple reactants, one product, it's a combination reaction. Those reactants were combined into one. An example is this reaction between sodium metal and chlorine gas. Here we have one element and another element, and they combine into one compound. A combination reaction, or a synthesis. We've made sodium chloride. Decomposition is kind of the opposite of synthesis. You get a complex substance decomposing or coming apart into simpler substances. So the general form of the reaction is like this. Here we have the compound, and it's decomposing into 2 different substances. It's coming apart. So the identifying thing here is you have one reactant. Combination reaction, there's one product. Decomposition reaction, there's one reactant. And so here is a battery in a beaker of water. And what's happening is that the water is decomposing into its elements, hydrogen and oxygen. Could we say that this is a gas evolution reaction? Sure, it's giving off a gas. So this could fall into 2 categories. Single displacement. So here we have one element displacing another in a compound. So here we have an element, and here we have a compound. This is like Adam, and here's Bobby and Christina. Okay, so Bobby and Christina. I gave her the name, and I can't even say it. Bobby and Christina went to the party together. But when they got there, Christina decided that Adam was a much better pick, and so she left with him. And Bobby was left alone. One person got displaced, a single displacement. Here's the chemical example. Here's zinc all by himself. Here's copper in a compound with chlorine. In this reaction, the zinc is displacing the copper. Now the zinc is in the compound, and the copper got kicked out. Okay, that is a single displacement reaction. Giggles. Yeah. Then there's double displacement. Okay, this you could liken to like wife swapping or something, right? Here we have two elements or groups of elements in two different compounds exchanging places. So here's Adam and, well, this must be Bianca now. And here is Carl and Deidre. I don't know. And now I've forgotten their names already. Adam and Bianca. Okay, so these two couples get together, and these are swinging couples, right? So now Adam and Deidre go off together, and Bianca and Carl are going to go off together. So, yeah, that's what can happen. And this one's written backwards. I just realized I'll have to fix that because the guy always comes first. That should be Carl and Bianca, not Bianca and Carl. So there are several different types of reactions that fall into this category, and we've used this scheme of swapping partners to predict products. We did this with precipitation reactions. In the precipitation reaction, one of these compounds is insoluble. That's what makes it a precipitation reaction. In the acid-base reaction, we had an acid and a base, and we swapped the partners, and we got water and a salt. And in a gas evolution reaction, what would happen is when we swap the partners, one of these, come on, pointer, one of these was going to be either sulfurous acid, carbonic acid, or ammonium hydroxide, which would then fall apart into a gas and water. So precipitation reactions, acid-base reactions, gas evolution reactions, those are classifications based on what happens, and they all fall into the same category under classifying things by what atoms do. So here's a classification flowchart for those of you who like flowcharts. So we can take chemical reactions and put them into these different categories: synthesis, decomposition, single replacement, double replacement. What you need to be able to do is identify what category a reaction is in. So let's look at this. This will show up as a multiple choice question on an exam, and so your ABC choices will be synthesis, decomposition, single displacement, or double displacement. And so we have to choose one. So let's look at A. What's going on here? Well, we have two reactants and we have two products. That means it can't be synthesis, it can't be decomposition. It's either single displacement or double displacement. So aluminum, is aluminum coming to the party with a date? No. And is aluminum leaving the party with a date? Yeah. Here hydrogen came with phosphate, and now hydrogen's leaving by himself. How many people got displaced? Just one, so that's a single displacement. So I'll call that SD for single displacement. Let's look at this next one. Here we have, again, two reactants, two products. That eliminates synthesis and decomposition. So Then we need to look at what are the atoms doing. Here we have copper and his date sulfate. We have potassium and his date hydroxide. And they're swapping partners, aren't they? Two people are being displaced. It's double displacement. We'll call that DD for double displacement. You see how it works? If you can grasp those patterns, then looking at this jumble of letters and numbers, you can start to see the pattern in there, and it's really not that bad. Okay, here we go. Letter C, we have two reactants and one product. Synthesis. We've got two things combining, and so this is a synthesis reaction. Synthesis. How about letter D? Decomposition. We have one reactant. One reactant is going to be decomposition. So first thing is to look at how many reactants and how many products. If either is 1, then you've got it nailed down to decomposition or synthesis. If you have 2 reactants and 2 products, then you're going to have to choose between single and double displacement, and you're going to look and see who's coming in by themselves, or maybe both metals are coming in as part of a compound. Any questions?